Two uniform, smooth, identical spheres A and B are moving towards each other on a horizontal surface when they collide. Immediately before the collision, A and B are moving with speeds UA and UB respectively at acute angles alpha and beta respectively to the line of centers. Immediately after the collision, A and B are moving with speeds VA and VB respectively at right angles and at acute angle gamma respectively to the line of centers. See diagram. Given that sine beta is equal to 0.96 and VB over UB is equal to 1.2, find the value of sine gamma. So here is our figure. Initial speed UA of A. We break down this velocity. This is a y direction, x direction. This is alpha. This is adjacent, so cosine, and this is opposite, so it's sine. And after the collision, this is perpendicular to this line, so VAX is equal to 0 and VAY is equal to VA, and so on. UB, this is beta, adjacent, cosine, opposite, so it's sine, and VB, this is gamma, this is gamma 2, this is adjacent, so we can calculate it with cosine gamma, and this is opposite of gamma. Because this direction perpendicular this line, we know, this is very important, that the y direction component doesn't change here and here, so this is very important condition. First, we know that these two conditions, we have to find sine gamma. We use this condition, y component of speed doesn't change, and this component is here, this component is here, they are the same, so we get that sine gamma is equal to this expression. This is 1.2 to the power of minus 1 reciprocal this times sine beta, so we get that sine of gamma is equal to 0.8. Given also that before the collision the component of A's velocity parallel to the line of centers is 2 meters per second. Find the value of UB and VB. So we know that UAX is equal to 2. We have to find out UB and VB. We can calculate beta and gamma from here. Second function sine. So they are here, and we apply the conservation of momentum to x direction. It means this momentum before the collision is equal to after the collision. We divide by m and substitute. This is 2. This is here. It's minus because this is our positive direction, and this is 0. It is here, and this. Yes, and we substitute VB. It is here 1.2 times UB. We write it here, and we write here, we calculate cosinus beta from here and cosinus gamma. So we get that UB is equal to 2, and VB from here 1.2 times UB, it's 2.4. Find the coefficient of restitution between the spheres. We can calculate it with this formula. We should use only x components. So it's this is our formula, and we can substitute from previous task, and we get this value. Given that the kinetic energy of A immediately before the collision is 6.5 times m joule, where m kilograms is the mass of A, find the value of V sub A. So this is kinetic energy of A. It's we can calculate it from this formula. This is very important. This is not millijoule, it's m mass. We can divide by m, multiply by 2 and square root. So we get UA is equal to 3.61. We are not ready because we know that this is the initial speed of A. We could see that this is 2 x component. Now we can calculate this component, y direction component. We can use Pythagoras. Square root of 3.61 squared minus 2 squared, it's 3, and V A y is equal to V A. It's 3 meters per second.